So in episode 3, we really focused around the forward plane and the control plane and the IS-IS protocol. So there was a lot in this one. What have we got in store for part 2 of the how-to?
Part 2 is going to handle VSNs, virtual service networks. It's going to handle Layer 3 VSNs. We're going to be talking about multicast. We're going to be talking about fabric attach, fabric extend. It's a full episode, but we're gonna make it easy to digest. It's going to be an interesting one for sure.
I mean, we're nearly at the finish line. This is episode 4, and stay tuned, guys, to the end where we will talk more about the certification exam and how you get access.
Absolutely.
Ready?
Yeah, let's hit that studio.
Let's go.
Most large networks have a large element of multicast on them. It is a fundamental concept and technology that is required in any modern network. And it's not particularly easy to do and set up. In episode 3, I cover that in some detail, but what I'd like to do now is just to go over some of the benefits of multicast over Fabric Connect. But more importantly, once I've gone through that, I want to go over the flow of the multicast within a Fabric Connect network. I think that will, seeing it, visualizing it, I think will make it a lot easier for people to get how good this technology actually is. So we covered in episode 3, we said things about the multicast over Fabric Connect. And we spoke about simplicity, how simple it is to actually set up, to configure, to provision. Those things are really easy to do. Monitoring, the streams as well that are going out. Those are easy tasks to do. Flexibility. Fabric Connect is flexible, and any layer that you put on top of that is going to adopt that same flexibility. There's no topology dependency, supports rings, meshes, all of those different types of topologies. Scalability. Well, we've already spoken about that. I'm not going to focus on that at all. What about convergence? I've worked for a company before that used to work on the delivery of video. And when you have multicast streams and they go down, it takes time for them to come back up. In the case of Fabric Connect multicast, if something goes wrong, you're talking about a convergence of around 200 milliseconds. Interoperability. In episode 3, we spoke about how PIM is a really complicated, difficult protocol to work with. But guess what? Under Fabric Connect works with PIM, and it works, of course, with IGMP, which are really the two important protocols when you're doing multicast. We have virtualization support, which means you can do multi-tenancy really well. So if you're an ISP or you're a large service provider considering using Fabric Connect, well, guess what? You can do multi-tenancy, multicast over multi-tenancy. So each one of those tenants can have their own multicast guaranteed secure stream. And finally, of course, security. Multicast on Fabric Connect is going to be secure on both Layer 2 and Layer 3 infrastructure as well. But instead of me telling you this stuff, let's just go and look at it, look at the animation and work through that. The sender has an IP address of 172.16.1.1, as you see on screen, and the multicast group that it's going to go to is 239.0.0.10. So now the multicast traffic is going to go in to a BEB, and that multicast traffic then needs to be advertised throughout the entire fabric so that it can eventually get to a receiver that's connected to a BEB. So all the receivers that want to receive that multicast stream, they have to be on the same customer VLAN, which you see over here as customer VLAN 100. And you do that really by associating them together. When the multicast stream comes into the BEB is going to automatically assign a multicast ISID, as you can see on screen. That multicast is then advertised throughout the entire network. At this point, it's not actually broadcasting multicast traffic. It's just advertising that it now has the ability to do this. And now it's waiting for one of these receivers to make a request to join that multicast stream. The way they do that is on the edge of the network, you need IGMP. IGMP, Internet Group Management Protocol, is a protocol designed to allow multiple devices to share a single IP address so that they can all receive the same data. Once the last hop BEB receives that request from the client to join that multicast stream, it then knows where to go and get that multicast stream, because ISIS has told it where to find that stream within the actual fabric itself. And because it's Fabric Connect, it always chooses the shortest path to go and pull that information down. Multicast over Fabric Connect really means that you can scale it up to having tens of thousands of multicast streams running across your fabric, probably more than any company or organization would ever need. Maybe if you're an ISP service provider, that would fit in perfectly with it. Ultimate scalability. So up till now, we've spoken about Layer 2 and Layer 2 VSNs. But Fabric Connect also allows you to have Layer 3 VSNs, Layer 3 topology on top of your Fabric Connect system. And this gives you an enormous amount of flexibility. For example, if you have many customer VLANs, distributed VLANs, and they might all be on the same VSN, on the same Layer 2 VSN, for example, you might end up with an enormous broadcast domain, which is kind of defeating the purpose. You don't want to have a broadcast domain that's really large. You want to segment your domain as much as possible, or your network as much as possible. So what you can then do is you can use Layer 3 routing to segment those particular local area networks, those large networks. You can segment them into smaller, more manageable, more efficient networks by using Layer 3 virtualization services. Of course, you can have multiple on any one of those BEBs. You can have multiple, possibly hundreds or thousands if you need to, routers, virtual routers sitting there, everyone segmented, everyone tenanted if you want, and if that's the service that you require. So let's jump in now into a little bit more detail on Layer 3 VSN and Layer 3 services on Fabric Connect. So in this example, you'll see a network on the left, which is a .30, and a network on the right, which is a .40, disparate networks. Instead of associating them with a global routing table, we can associate them with a VRF, Virtual Router Forwarding Engine. That VRF, of course, is created on the BEB. So you create a VLAN, you give it an IP address, and you associate it with the VRF. And that then becomes a VLAN only in the context of this VRF. On the right side of the network, you do exactly the same thing. You take this separate or different subnet and you associate that with a VRF and just follow the same procedure. The next step that you'd want to do is you'd want to distribute the routes from one VRF onto the other VRF. And the way to do that is to create a Layer 3 VSN. So instead of associating a VLAN to an ISID, what you're going to do is you're going to associate a VRF to an ISID. Then you turn on IPVPN, and on each side, on each BEB, well, this has to be done on both BEBs, you then turn on the feature redistribute local routes. So in essence, what we're doing, we're creating an IPVPN between VRFs for IP route redistribution. This applies only to the selected VRFs, much like VSNs. Multicast, of course, is supported in this configuration. The BEB is going to create automatically a multicast ISID for each SG. So inter-VSN routing allows us to take a VRF, place it into the network, and then create a couple of customer VLANs, and then extend these VLANs to anywhere within the fabric. The network on the left will now use that VLAN as its default gateway, and the same thing applies to the customer network on the right. What this means is that you can then have these devices on the left and the right communicating with each other using that VRF in the middle. Fabric attach. The ability to endpoint provision ISID services to a non-SPB device. That's a lot to take in. Let me take one step back and talk about a particular protocol that enables this type of technology called LLDP, Link Layer Discovery Protocol. So why is this so important? When you power up a device like a network switch or, for example, an access point, the link pulses will tell the other devices, hey, I'm on the network, I have power. And at that point, the very next protocol or the very first protocol that's going to run over that particular port will be LLDP, the Discovery Protocol. And what it basically does is advertises itself onto the network. And it talks about what device, what type of device it is. It also talks about its capabilities. So imagine an access point plugs into the network and it says, I'm access point so-and-so, this is the model number, this is the technology that I support. Same thing for a switch. I am this port, I am this switch, I have 24 ports, I can talk at this speed over all the ports, 10, 100, 1000. So you get the idea, it talks about itself. Not all devices use LLDP, certainly Extreme Networks devices do, and there are many other vendors that have started to implement this on their devices as well. And that creates an interesting situation because you can then, with Fabric Attach, start to provision endpoint devices. So if you have determined that if an access point is added into your network, you want to provision it in a certain way, then Fabric Attach will make sure that when that happens, when you switch on that access point, it advertises itself, and Fabric Connect can then carry that provisioning information to that device and set it up automatically without you having to do massive amounts of manual work. And we definitely want to avoid that because we know there's always mistakes that are made in situations like that. So on screen, what you see is a diagram, the traditional SPB network that we've been using throughout this training, Fabric Connect in the middle with ISIS being the protocol. We see the customer VLANs, we see the VSNs there. And then to the right, you see an Exos proxy, an Exos Fabric Attach proxy. So this could be one of our Exos switches that is not SPB aware, that is not Fabric Attach aware, but yet you see to that we have an access point that's a Fabric Attach client. And that access point might be talking to a consumer, and most probably is a consumer, one of your office staff. And so that, as you connect that into the bridge, that Exos FA proxy basically just passes that information, that link layer discovery protocol information, it passes that through that particular switch. So it really acts as a proxy and it puts it onto the BEB, which then does the work that it needs to do to provision that. And of course, if you think about this on a network, on a local area network, these types of devices, these switches that you see are in your wiring cabinet. The access points would be, within your premises. They don't necessarily need to have a spanning tree protocol on them necessarily, because they can then talk to this proxy. The proxy passes the information onto the BEB, and that is how they are provisioned, and they can still function even if they are third-party devices. As long as they have that LLDP, they are able to connect, advertise themselves, and the network can start interacting with them and provisioning them in the correct way. So now we come to the all-important part of security. I want to cover three things in this module. I want to cover hyper-segmentation. I want to cover networking by stealth. Finally, I want to cover elasticity. Now, security is not a band-aid, right? You hurt yourself, you put a band-aid, it goes away. Security is not like that. If you think about security, you have to think about an end end-to-end approach. There are just too many vectors on a network nowadays for you to just put a band-aid on one of them. So take a look at this diagram and let's talk about point 1, hyper-segmentation. A lot of people refer to this as the holy grail of networking. So imagine for this example that we're talking about a university campus. Cambridge University here in the city of Cambridge is a good example. It's a distributed university, meaning that it has little offices and little campuses all over the city of Cambridge. Some of them are large, others of them, the more specialized ones, are quite small. They have laboratories, research centers. They have all of those things. But I am sure that in every one of those offices, they have somebody there who is working with HR. Okay, maybe not all of them, but in many of those offices, they're going to have HR people. They might also have a central location where a lot of the HR team work. No one should have access to that HR network except the HR people. So traditionally, what we've done is we've put HR people into VLANs, right? VLANs are great. You can put everyone in the HR team onto a VLAN, and that works really well. But when you start getting beyond the 100, 200, when you start getting to the teams where there are thousands of people, maybe, VLANs are not that great. They don't scale particularly well. And then you have to start using VLAN chaining to put all of these people in the HR department into one particular VLAN. With Fabric Connect, you establish a VSN, and guess what? It gives you that security of putting all the HR team into one network, and it is fully scalable. It doesn't matter if you have 3 offices or you have 300 offices. As long as you set up the VSNs between all of those offices, it's hyper segmented. There is nobody else that can get into that particular network. And because it doesn't require the maintenance overhead of a traditional VLAN setup, it makes it easy to then apply that to so many different departments. Because of the complexities, you would have put HR and finance together, for example. But in Fabric Connect, each one of those, it's hyper segmentation. You can hyper segment it to an infinite level. That's fantastic. That really is going to be part of that end-to-end solution. So that's the first thing I want to talk about. The next thing I'm going to be talking about is stealth, networking by stealth. It's not common phrase that you often hear. But look at this diagram on screen right now. That's a traditional network, right? An IP-based network. Each one of those devices that you see, they have addresses, IP addresses. Each one of those devices is reachable. Now, of course, this is inherently not a great way to design a network. You'd put VLANs in there to segment these different things. However, you still hit that problem with VLANs about scalability, right? And the management, the overhead management that goes on to setting that all up. Now, look what can happen over here. If there is a breach, for example, in this IP camera system over here, if you were to run a trace route, well, you could find the IP address of all the devices along which that particular trace route goes. If you did a port scan, many of these devices you see over here would respond and say, hey, I have port 80 open, I have port 443, I have port 25, I have this port, I have that. And it would be very easy for you to build a map really quickly of all the ports that are open and vulnerable to being attacked. That's not a good situation. And of course, like I said, that's one of the reasons you use VLANs, but these are the problems that you have with VLANs when you scale up. In Fabric Connect, look at this picture that you see over here on screen. It is obfuscated. So if you have a CCTV network, you put each one of those cameras, each one of those devices into a VSN, including the video server. You put those into a VSN, and any breach of one of those will show you what? Well, if you do a trace route, you are not going to see all the IP addresses of everything in between. All you'll see is the entry point and the exit point, because what happens inside of that Fabric Connect network is obfuscated. It's hidden. It's there. It's networking by stealth, somewhere there. But there's no way to get it because there's no IP addressing. Think of it as the London Underground. The London Underground, the oldest underground in the world, it's got like 18 tube lines within the London Underground. To get onto a tube, you have to go get onto that station, get into that tube, and then go to the next station. While you're in the train, while you're in that tube, guess what? You can't jump onto anywhere else. You are bound. You are stuck in that tube. You can travel between those two stations 500 times in your one, but you can't jump in that train from one to the other. You have to exit at the next station, the VSN destination, and at that point, you can go onto another station, onto another line. That is the beauty of this networking by stealth. So not only do you hyper-segment your users in a network within Fabric Connect, but now when they work, they are completely invisible to anybody else on the network. It's as if they didn't exist. The next one, which pairs really well with number 1 and 2, is the concept of elasticity. So taking that example of the University of Cambridge again, policy will determine, I know exactly who that user is. They're part of the HR team. Guess what? That VSN is automatically expanded. It expands to reach that particular user with zero input from the IT people, from the networking people. They don't have to go there and set up a VLAN and do all. It doesn't matter. So that HR person, wherever they travel in the network expands, right? Like an elastic, it expands to reach them. And what then happens is when they leave, when they've worked a couple of hours and they got to come back, the network retracts, just like an elastic band retracting again. If you, Tommy Clever, and you decide to plug into the HR people has gone, let's plug into that network. Guess what? That VSN has been retracted. There's a dead network point. There's nothing. You can't get onto the HR network without having to do anything. And why is that such an important thing? 3 years ago, networking engineers, security engineers had to look after essentially one location. We have our offices in the UK in Reading. You go to Reading, there's a whole lot of people in that building, and that's the building that needs to be protected, the location that needs to be protected. But today we're living in the world of the infinite enterprise. Where is the enterprise? It's here, it's there, it's the office, it's my garden, it's the coffee shop, it's an airport lounge. Where is the infinite enterprise? It's nowhere and everywhere. And now you need to be able to extend that security to any location, anywhere around the world. Fabric Connect enables that type of technology. That is the infinite enterprise. And Fabric Connect is so ready to handle that type of enterprise. I hope this has been helpful to you and given you an overview of the functionality of the features that exist within Fabric Connect to help you plant and develop and grow a secure network. 3 very important things: hyper-segmentation, networking by stealth, and elasticity. A while ago, I was watching a video by Ed Kohler, one of our technical fellows at Extreme, and the title was called Networking by Stealth. I found that really interesting because he explains and unpacks the security benefits of using Fabric Connect in a network. If you have any interest in this, we'll put up a QR code. We're not going to play it here because it's a little bit too long. Follow the QR code, go and watch it. I think you'll really enjoy that presentation. Let's talk a little bit about Fabric Extend. If you have a Fabric Connect network, as we've mentioned in previous episodes, it really is not limited to a particular size. So you could use it in a small organization, but you could also use it in a massive organization. And if you get into that situation, like hospitals, like campus, like government buildings, then you often find that these locations are distributed. So campus would be within an area. In Cambridge, the university has multiple buildings, campus network. But if you have a distributed university that has campuses all around the country, that makes it a little bit different. But even if you've got that type of a network, then Fabric Extend can help you, because Fabric Extend is going to be able to allow you to extend the reach of that fabric network. So you're going to get benefits such as service provisioning right at the very edge with things like seamless layer 2 extensions, completely seamless layer 3 extensions as well as full IP multicast support. Some of the benefits of using Fabric Extend, it can extend over third-party layer 2 and layer 3 networks. Think about that. It can extend over layer 2 and layer 3 third-party networks. All Fabric Connect features, all the benefits of Fabric Connect remain intact end to end. You have fully redundant deployment options and overlay network enablement as well on top of that. And all of this can be configured over LAN, over WAN, and even over the internet. Yeah, you heard that right. Even over the internet, you can use this to extend the reach of your fabric. Fabric Connect is a technology that all network engineers should at the very least examine without bias or prejudice, and that those holding the purse strings should take a very hard look at, because it really does offer the ability to lower network management costs while still providing the essential elements of agility for the companies that want to move ahead at extreme speed. If you found this technology interesting, this is really just the start. If you want to find out more, there's tons more information that you can find out on our website, or send us an email at learn@extremenetworks.com. Now I'll hand over to Claire, and she'll tell you so much more about the exam and what the next steps are. Thank you for watching.
So this is the section where I'm going to briefly talk to you guys about the certification exam for Fabric Connect. Now, if you're new to Extreme, you will need to create yourself a portal account. So if you use this QR code, it will take you to the registration page. Once you've created yourself a portal account, this will give you access to the Extreme Dojo. Now, using this QR code, it will take you straight to the Welcome Series Extreme Fabric exam. Now, once you've got to the exam page, please make sure you are reviewing the exam requirements. So this is how long the exam takes, how many questions you need to answer, and the pass mark. And once you've gone through the exam and hopefully completed it, that's it. You are certified for free in Extreme Fabric Connect. So that's all you need from us, from the teaching to how to access the exam. Now, don't forget to contact us at learn@extremenetworks.com if you have any questions. And remember to follow us on LinkedIn. We'll show you the QR code now. And again, it's a great way to communicate with us, the Extreme team. Best of luck with the exam, and we'll see you next time.
If you have an interest in learning more about Fabric Connect and use cases, we have a great resource for you. Just follow this QR code on screen and you can go and get yourself a book called Fabric Networking for Dummies. Fantastic resource, completely free.